So I think we can slowly start. Thanks for coming. My name is Nick, and you can find me on GitHub, probably also on Twitter somewhere. I'm going to talk about Scala plus Android. You may have seen a slightly longer title, but that's what it is, really. How many of you have heard about Swift? Okay, great. So this came up on the Swift dev Twitter, and they say, well, now that we have Swift for iPhone, Android friends should also get a normal language. And well, I agree, actually. And we do have a normal language for Android. That's what this talk is supposed to be about. But before going further, I would like to discuss why is it that we really need a good language for mobile development. And I would posit that it's because mobile development is hard in the sense that it has some non-trivial problems. So we have a lot of devices which are all different in sizes, and we have to adapt to that. We have lots of interaction because, well, the device is small, so it's always in your hands. You're always doing something with it. The interfaces do not really fit on the screen, so you have to scroll a lot. You have a lot of smaller interfaces that you have to use. And it's not always connected, so you have to be asynchronous or reactive in a way. And something especially true for Android, it has some very Java-like APIs. So since we are talking about Android, a small wrap-up. So it's a very popular mobile platform. They design their logos and version names after candy names for some reason, and it's quite hard just because of the things that I mentioned. And well, let's see if we can use Scala to actually overcome these problems. And Scala actually works on Android, and it does solve some of these problems. And I think it's fun, and everyone who's here at Scala Days, I think, would agree with me. So the first problem, I think we could start with the simplest ones, is really dealing with these APIs. So Android is full of these nulls and all other nasty things, and we can use options, which really help. And sometimes you can do stuff too early, because, for example, the user interface is not ready yet, so you can touch the buttons or do other stuff, and we can use lazy values for that. And there is also an experimental feature in tuple 11, which will help us to use less anonymous classes. And well, obviously you can also write a lot of implicit conversions to get a more streamlined Scala API. And there is a project called Scaloid, which already has most of these implicit conversions, so probably it's just easier to use that. And you can see that it gives you a really significant reduction of boilerplate. But I think that the more interesting problems are, for example, that of concurrency. So basically you have the main thread, which is the UI thread. And on this thread, you can really only do UI code. So you can move buttons around and change captions and not really do anything else because the application will just freeze. So what if we need to do some work in the background and then show the result to the user? Well, the Android way is really ugly. I'm not going to show it, but it's called async task. But in Scala, with the help of some utilities, we can just use futures. So we say, well, run a future, and then we put some background code into that. And we can use this method, which comes from Macroid library that I discussed later. It's called onSuccessUI. So it will handle the result of the future on the UI thread. So then you can update the user interface and show the data to the user. And it's well, it's pretty convenient, and it's also very concise. And since people here are not visiting the Scala-async talk, I assume that everyone knows Scala-async, right? Who knows scala-async? Yeah, most people do. So, well, scala-async is another very helpful thing. So, in the same fashion that we do that with futures, we can actually have several futures and manipulate them asynchronously inside this async call. So, for example, this could be two pieces of data that come from different databases over the network, and then again you can do something with the result on the UI thread. So another Scala library which could be really helpful is Akka. So why would you use Akka on Android? Well, suppose that you have a big composite interface with several panes, and you have data coming from this cylinder and this cube, whatever they are, so different web services, and it's all asynchronous, and when you move a slider in one part of the interface, something happens in the other part of the interface. So this really seems like a good use case for Akka or for actor model in general. So you can attach an actor to every piece of the interface, and then use these actors to communicate with each other and with the external services. And there is an activator template that does kind of this thing, but on the easier level, and it has a tutorial, so you can check it out. Finally, there is another problem, which is that the phone can go offline. So normally what you would have is you make calls to REST web services or any kind of web services, but you also have a local database with objects. You have file caches for pictures. And what happens if you need to load some kind of data structure, but all the pieces of this data structure come from different sources, and you want to optimize? So if you have it in the local cache, you load it from the local cache. If it's not there, then you go to the web service. So you try to save traffic, and you try to optimize for things that you already have. So there is another library that I wrote, which is called resolvable, and it helps you to deal with this. So Scala really shines in the concurrency department, and I think that it's a great help for any Android developer. But we are left with the two probably biggest problems, which is how to maintain interaction with the user, and how to adapt to different screens and different devices. So this is a library called Macroid, which I wrote, and it's experimental modular functional UI language for Android, and it's written in Scala, so it's just pure Scala library. Well, the motivation for Macroid comes from the way things are done in Android. For example, if you just want a text box and a button below it, you have to write this kind of XML code, which I think everyone here would agree is pretty ugly and verbose. And you can't even have behaviors in this code. So if you need to attach on-click handlers, you have to go to Java code, and also now you have two things to manage. And you can only put one graphic layout, so buttons and text boxes, in one XML file. So if you have like 100 smaller pieces that you want to combine together, you need 100 files. And there is no namespacing scheme for them. You can't put them into folders. So you end up with your namespace spoiled with all these XML files, which have very tiny pieces. And if you want to adapt this for several devices, then for each screen size, you create a version of each XML file. So it's duplication to the absurd degree. So let's step back a bit and see if we can use code to define our layouts. What if we want to just create a button, for example? So we can just use the Java API, which looks like this. Well, it's not really nice because we have a lot of noise. So we have this new keyword, we have the context that we have to pass. And what Macroid gives you is what I call a brick. So it's a thing that looks slightly better. It takes less space. It's very concise. And it uses a macro to expand to just this. So Now that we have bricks, we can also build more complex layouts. So, for example, this is more or less the same as the XML sample before. So you can see that it's much more concise, and you can see that now it's a layout with the text view and the button, and all the unnecessary stuff is gone. And well, you can put layouts into Scala values, you can put them into objects, and you can put 100 smaller pieces in one file or in 100 files. So you can take advantage over the Scala's modular nature, and you can compose this in any way you like. But what if we want to tweak our widgets? So we don't just want a button, we want a button with a caption, click me. So somehow we have to set this property. And one way that we could do this would be to just call a method text. But if we think about this, something which sets a property could be an object on its own. So in this case, I call it a tweak. So we have a brick, and we are tweaking it with this text tweak. So what text does is, well, it sets the caption of the button. And you may probably ask why you would separate this as an object. Well, if we have two properties that we set, we can do the same thing. So if you use methods, you would just call two methods. But on the other hand, we could do this. We can create a new tweak, which is just the sum of those two. So we're just composing these tweaks to make kind of styles, if you will. And here we are also adding some padding. So by using this, we can have composable layouts and composable styles. And here's a bigger example, in case you were wondering how it looks. So we have a button and a text view. And well, we have a slot for our text view. And we assign a caption to the button. And we set an on-click handler. So when we click the button, the text view is shown, and it has the caption without greeting. So it looks pretty compact, and it's surely much more compact and concise than XML layouts. But if we go back for a bit, well, this tweaking thing, we really used it to configure a button with something which was a tweak of a button. But if we think, we could actually tweak a list of buttons, for example. So we can take a list of 10 buttons and hide them just in one command. Or we could apply a list of tweaks to a widget, or a list of tweaks to a list of widgets. And, well, it doesn't stop there, because we can actually use options and futures and any kind of constructs. So the way it works, we have this type class, which is called canTweak. And we can say that this is tweakable with that for any sorts of this and that. And we get our end result. So, for example, if we have a caption, which is a future of string, so it's a caption that will come like in 5 minutes or 10 minutes or at some point in time. We can map this future caption onto the text tweak. So we can apply this caption right now. And when the future finishes, the caption will change. So we don't have to write any kind of listeners or boilerplate code. We can just change properties with futures. And if you have seen the RX talk yesterday, we can also use the RX, but I'll show this in an example later. So one problem is that not all changes of properties are instant. For example, if we want to fade in our button, wait until the fade in is finished, and only then we want to assign a caption. Tweaks don't really help us. So we have some kind of a wait at this point. And that's why Macroid also gives you something called snails. So in this example, we have a button, and we apply fade in for 400 milliseconds. Then we set the text, and then we apply the fade out. So we use these double arrows, which mean that we wait for the snails to finish. So you can declare these kind of asynchronous workflows in this very concise manner. So you don't have to write like nested spaghetti code with event handlers. You just write this, and it all happens asynchronously. And well, as you may have guessed, you can also compose snails. So we can, for example, define a new one, which is called blink, and it's basically a combination of fade in, a delay, and a fade out. And then we can apply that one. So finally, we also don't, well, these tweaking instructions, they don't really do anything. They just return a so-called UI action. And UI action is a piece of code that you can run on the UI thread. So it's also thread safe, unlike the Android API. So you define this action, and then you say run UI action. And we can combine these actions. So we have one action that changes the caption of the text view and shows it. And we have another action which hides a progress bar. And then we can run these actions in sequence. And we can actually get a bit more elaborate than that. So we can combine actions asynchronously. So we have an action that fades out the progress bar. We wait until this action is finished. Then we blink the text view with the snail that we defined before. And only then we change the caption of the text view. So to write something like this in pure Android, I guess you would have to write a couple of callbacks, and this will be really a lot of code. And well, we use these double operators wherever the things get asynchronous. So it's pretty easy to tell if it's waiting or not. Okay, so well, we also talked a bit about the adaptive thing. And what happens is that all Android devices have different screen sizes, and you can also use them in different orientations. So what Android gives you is you can define different versions of your XML file and put it in different folders. But that's not really composable. And what Macroid does, it offers a thing called media queries, which is inspired by CSS media queries. And you can define very small adaptive pieces. So for example, adaptive size is a tweak which changes the text size depending on the screen size. So if the screen is wider than 300 device pixels, we have a large text size, and if it's not, we have a medium text size. Yes? Well, actually, what happens when you rotate your phone, your activity is created again. So this would happen, yes. Yeah. Well, also, what we can do is, if we have, for example, some kind of sensor, we can have some kind of event stream for this sensor, and then we can map this event stream onto the respective tweak, and every time the sensor changes, the tweak will happen. So we can do that as well. So for example, well, you could probably write code that does this. When you shake the device, the text size gets bigger. So when you're in the street and the device is shaking, it gets bigger so that it's easier to read. Well, this actually brings the question of how do we actually run Scala on Android, and if there are any problems. And I guess that's the main part that you were interested in. So, well, let's revisit somewhat the process of writing Android apps. So you have to prepare the project. So you have to set up the build system, the IDE and stuff like that. then you write code, then it's compiled, it's packaged into Dalvik format, which Android uses, and then you run your code. And these colors here actually illustrate the difficulty or the degree of pain associated with the respective steps. So if we start with the prepare, coding, compile stages, well, they are pretty easy. So I would say that the main thing is to choose a build tool. So you can just use an IDE, both IntelliJ IDE and Scala IDE work. So you just create a project. Well, in IDE you have to add Android facet, add Scala facet, and then it just works out of the box. I haven't used Scala IDE recently, but I think it works as well. And although you have to install this plugin that is in the link below, but well, with this approach, it's very easy. But you also don't have automatic dependency management, for example, that you would get from a build tool, and you're really binding into a specific IDE, so if at a later time you want to change to a different IDE, this would be not very convenient. So another option is to use SBT, and there are actually two plugins, but this one is actively maintained. So you just set up an SBT build file, you add this plugin, you can generate project files for IntelliJ IDEA or Android Studio, which is the same. And you get dependency management, so you can use Android libraries and whatnot, and you have build automation, so you have all these test, clean, build, compile, run commands. And well, there is only one downside, which is not a downside for some people, but you have to learn SBT to do that. And you can also use Gradle, which is what most people in the Android world use. So there is a plugin for Gradle to be used with Android and Scala, and here's the link. And well, again, it's the same advantages and the same disadvantages that you have to learn Gradle, or at least know how to use it. And now comes the real pain point. So, which lies in the Dalvik VM that Android uses. So, well, first there is a limitation, which is 65,000 method limit. So, because of that, you have to use a tool called ProGuard to remove all the excessive methods from your code, so the ones that you don't really use. And if you use Scala library, or Scala runtime library, it's pretty big, so it's like 6 megabytes in 2.10 and 5 megabytes in 2.11, I think. And also there is a conversion step involved, so you have to convert from jars into this Dalvik format, and this really takes time. So you have these two steps, which is ProGuarding, so removing excessive things, and dexing, which is converting to the Dalvik format. And for small apps, like really small apps, it could be like 20 seconds, so it's pretty much the same as normal Android. But I have an app which is around 10,000 lines of code in Scala, and it uses a lot of libraries, and a clean build takes about 2 minutes. So, well, it's a big price to pay, but on the other hand, using Scala gives you other advantages like concurrency support and more flexible user interface design. So now I would like to do a little demo. Yeah. So, well, who has been to the Scala RX talk yesterday? Okay, quite a lot of people. So this is basically the same example that was given yesterday, but for Android. So what happens is we have 3 reactive values. So the first value is just, by the way, can you see it okay? The colors and stuff? Okay. So the first reactive value is value of 1, and the second is initially 2. And the third one is the sum of these two. And what is very cool with this RxClean is that once you update the first or the second reactive val, the third one would update as well. And what we are going to do is we're going to put these values into text boxes, and you would click the text boxes and the values on them would update. So what we have here is something which I defined previously. So it's a Rx text tweak, which basically takes the reactive variable and maps it to the text tweak. So it says the caption of something. And I have another tweak which is called RxClick. What it does is increments the given reactive variable when you click on something. So what we have to define is the style of our buttons and, well, basically the layout with our buttons. So let's start with the layout. So we'll be using vertical linear layout, and it would have 3 buttons. So we'll attach this style to them, and also the first one would get Rx text from variable 1 and Rx click from variable 1 as well. Yeah, and now we just duplicate that. This one actually doesn't have any click handlers. This should be 2. This should be 2 as well, and this should be 3. Right. So now this style, I'll go for a large text size and some padding, which will be 16 device pixels from every side. Okay. So let's see if it works. I'll do a clean build just for the sake of this demonstration, so that we can time this and see if it's really that slow. Okay, so now it's the ProGuard step, which filters out the different libraries. If we launch it the next time, it will actually be much faster because the ProGuard output is cached. Okay, so now it's installing the app. Let's see if it works. Something else failed. Okay. Yeah, it does work. So when we click on that, the third one changes. And you can see that we didn't really write any big, heavy listeners or any of that sort. So that was pretty simple. We just had 3 reactive values, some styles, and some tweaks. And that's actually pretty much it. So there is a mailing list, which is called Scala on Android. And if you have any doubts, you can ask questions there. It's not very active, but some people answer almost everything that comes up. And you can get the PDF for this presentation so that you can follow all the other links in the slides on the Macroid's website. So there is a talk section, and the slides are already there. Thanks. Any questions?
Hi.
Hi.
Do you have some thoughts about Scala 2.10 versus 2.11 for Android development?
Well, I haven't really benchmarked this, But one thing I can say is that it's obviously 1 megabyte smaller, or something like that. Am I right? Yep. Yeah, so it's better. It doesn't have scala.xml, which I don't think people use on Android, or at least I can't think of a reason to do that. Other than that, I haven't really tried the single abstract method expansion yet, because most libraries that we use on Android already have implicit conversions from the listeners. So it's not something that is needed very often. The experimental features like macros I already use on Scala 2.10, so it's not a big difference for me. Yeah. But probably if people use it more, maybe something would come up. So maybe if someone benchmarks it, it actually turns out faster or smaller or whatever. I think it would be pretty reasonable to expect that. Yeah.
How about the size of the app?
Okay, so this app that they have, which is like 10,000 lines of code, and it has a full dependency on 2.10 library, which is 6 megabytes, and a lot of other things. It's like 2.8 megabytes. Yeah, it's small. So because you use ProGuard, everything that you don't really use is stripped out, so it's not a big issue. Apart from ProGuard taking time to do that.
Hi.
Hi.
It's more a statement than a question.
Okay.
There's also a possibility to dramatically reduce the turnaround times by skipping the ProGuard step when you pre-install the Scala libraries.
Yeah, that's true. I forgot to tell about this. So there is one option is if you have a rooted phone, you can pre-install the Scala libraries there. And there is also a script to install Scala libraries inside the emulator. Yeah. So yeah, that's an option. But if you are doing a release build, of course, you still have to use ProGuard.
Yeah,
yes. Yeah. And I would imagine that if you use preloaded Scala libraries, the DEX step would actually take more time because it has to process or maybe not. But yeah, that's an option.
No, yeah, the DEXing is done before, so that doesn't take any additional time.
Yeah, that's true. Yeah.
And it works for Ganimation, for emulator, and for real phones as long as they are rooted.
Yeah, yeah, but for some people, rooting their phones is not an option. Or using an emulator, for that matter.
Why would anybody not use this?
I guess that was that was a statement as well.
Hi, you mentioned about using Akka for inner fragment communication.
Yes.
I'm wondering whether, like, Akka and all of these Scala libraries are usually conceived for server-side use. So is the default Akka configuration suitable for Android, or do you need to provide your own special configuration given the device constraints?
Okay, so, well, one thing about Akka is that Akka does have a lot of classes, so you have to configure ProGuard properly. And Akka uses a lot of reflection to load things from configuration and stuff like that. So if you go to this template, which I have somewhere, it actually has a pre-configured ProGuard rules. So for most basic things, I think it would work. If you use something which I don't use, then you have to add your own rules. This is regarding ProGuard. And regarding Akka, well, you don't really need any kind of special configuration, but you can certainly do that. So if you want, for example, your actors to run on a specific thread pool or a specific type of executor, or have a specific type of mailbox, which is sometimes what you need, then you can definitely configure that. And you can also configure a custom logger to log from Akka to the Android log, which is also something that I have in the template.
Could you please compare the main features of Scaloid and MacroidMACROID?
Yes, sure.
And maybe the resolver library.
So Well, first of all, in case I forget something, if you go to the Macroid website, it has a page on that. So I'm not going into detail on all this, but because you can read this yourself, I would probably answer from a different point of view. So I think the goal of Scaloid and Macroid is a bit different. So Scaloid is trying to make it as small as possible. So there are implicit conversions for everything. And well, the goal of Macroid is a bit different, which is to allow something which was not really possible before. So you can have more complex interactions with that. And for that, sometimes you have to give up a bit of conciseness. So sometimes the code is a bit more verbose, but it's much more flexible. And one thing is that Scaloid relies on its own custom classes. So you need to use sButton, sTextView, and so on. And Macroid uses a macro to expand bricks. So you can use any kind of widget, widgets from the standard library or custom widgets or whatever. Yeah, so it works with everything. I think that's the main difference. But there are also some subtleties like in concurrency support and other things.
I have another quick question. How do you feel about Java 8? Are you worried that libraries are going to switch and you won't be able to use them, or tools like ProGuard going to rewrite to Java 6, like retro lambda or stuff like that?
Well, if we remember how long it took for Android to support Java 7, I don't think it's a very near future concern.
Well, what I meant was if the community moves to Java 8, you won't be able to use their libraries because the DEX tool, I guess, won't support the new
okay.
format.
Well, I haven't really thought about this, so.
Hi.
Hi.
You cannot write widgets with the Macroid, right?
What do you mean?
Widgets. You know, on your screen, such things.
Could we write widgets?
Yeah.
Well, I guess you're asking if we could, for example, write a new class button or something like that. But I think that the technique that works...
No. I'm asking about the widgets, Android widgets.
Ah,
because
okay.
They actually rely on the XML and the stuff.
Okay. I haven't tried it, so I don't really know. I was confusing with the widgets in the sense of buttons, text boxes, and other stuff. But
because they run in different process, they widgets actually run in the screen, home screen process, and because of this, they need these XML resources, and you cannot.
Okay,
actually...
well, if you can't use Java API to write them, then you can't use Macroid.
Mm-hmm. Thanks.
I wanted to ask a little bit about the DSL.
Yeah.
For me personally, I find it a little bit confusing, maybe.
Okay.
With all of these single letter definitions and the different amount of tildes between the definitions as well. How would you comment about that, or do you have any plans to make it a little bit more readable, maybe?
Well, there are actually just two letters, so it's L and W is widget, L is layout.
I understand.
And well, imagine that if you have a bigger layout, so like something like this, yeah. If this would be like not one letter, but some kind of method call, well, it is a method call, but if it would be some kind of big identifier, it would result in a lot of visual noise. So it's really like just a bracket. It's not something that should draw a lot of attention. Well, not really, because you have to call a macro that would expand this to a new button with the context and stuff like that. And regarding the arrows, well, there are actually just two types of arrows, so the single one and double one. And the difference is that the single arrow is instant, and the double arrow waits for the completion. And if you go to the documentation, there is actually a separate page explaining the difference between the arrows and the design choices. Yeah.
Okay, so can you go back to the slide with the DSL example? Why do you actually need two letters L and V? Can't you just expect the type that is given in brackets in a macro and use the same one?
Well, actually, they are different macros. So if you take a look, the W macro, it just creates a widget, and the L macro, you have to provide children to it. So they are different macros, and not to mess with the overloading, it's much easier and better to use two different things, I think.
And the next question is that instead of having all those L and W's inside nested in one another, you could have you tried to do it as a string interpolator?
No, not yet. I was thinking to do something like compile this not just to code, but to some kind of H list, which then can be run as a code. But I mean, that's just a crazy idea.
Hi.
Hi.
Do you support also other FRP libraries than Scala RX, or is it tied to this one?
So the thing is that the definitions for Scala RX and Scala.FRP, they were in the Macroid library, and now I'm actually pulling them out of it. So there will be a new library called Macroid-VRP, and it will have support for several of them. And actually, the support is this. So it's not very complex. You just have to define a type class instance, and then you can support any number of RX libraries, including RX Java, Scala.RX, Scala.FRP, which has event streams and so on. Yeah.
How experimental is the project?
Well, I mean, actually, it's a word that stuck somewhat. It's experimental in the sense that its goal is to try new things and things that were not possible or very hard to do before. So it's not probably experimental in the sense that everything doesn't work or everything breaks. So I use it in a big application. Actually, the code base is not very big, so I would say that it's pretty stable just because it's quite simple in the implementation. So it's more experimental in spirit rather than in the state of the code. I haven't compared directly because I don't have a same application written in Java, but generally, thing is that there are much more memory consuming things in Android. For example, if you use an Android map, which is embedded as a fragment, it already takes like 20 megabytes. So it's already probably half of your application. It's pretty big, and also if you load bitmaps, if you're not careful enough, you may get an out-of-memory error. And I don't think I ever got an out-of-memory for just using Scala. So it's not the most memory-consuming thing. Well, mostly I tested with the devices which were introduced after 4.0. So not like very old devices, but I would suppose that normal code would work. If you are doing something really heavy, like doing a lot of immutable collections, probably you shouldn't do that anyway. So you can always use mutable collections or for loops, while loops, and stuff like that. Thanks.